So what is an inverter? Inverter is a circuit that is used to convert DC voltages into AC voltages. So in the previous class that was held on 16/10/2020 దాదాపు 2 నెలల క్రితం మనం క్లాస్ చెప్పుకున్నాము. ఆ 2 నెలల క్రితం మనం చెప్పుకున్న క్లాస్ ఏమిటి అంటే దిస్ ఈజ్ వాట్ I explained you. Operation of single phase bridge inverter. So the output of bridge inverter is square wave in nature. The problem with single phase voltages is most of the industrial applications will require three phase, not single phase. So you might have a doubt. So we are using three phase. Why you taught us the single phase, isn't it? So if you study the operation of single phase inverter, then it would be very easier for you to understand the concept of three phase inverter. Okay, so what is the similarity between a single phase voltage and a three phase voltage? The similarity is that three single phase voltages are displaced by this displacement is nothing but the electrical displacement. This displacement, what we call it as electrical displacement by 120 degrees with respect to each other. That means VAN is Vm sin omega t. Then VAN is the phase voltage of A phase. Then VBN is also equal to Vm sin omega t, because it is a sinusoidal voltage, but which is lagging behind the A phase voltage by 120 degrees. Similarly, VCN is equal to Vm sin omega t minus 120, which lags behind B phase voltage by an angle 120 degrees, which is equal to 240 degrees. So this is what we call it as the phase angle, isn't it? So there is no difference between the shape of the voltage that is required to be produced at the output terminals of an inverter. So if it is possible for us to produce three single phase voltages that are displaced by an angle 120 degrees electrical with respect to each other, it is possible for us to generate or produce three phase sinusoidal voltages with the help of an inverter circuit. So for that purpose, what we do is we use three single phase bridge connected inverters, and they are connected either in a star fashion or in a delta fashion. For example, this represents a H bridge inverter. So which will be having switches like this. Okay. So V1 is the voltage, V01 is the output voltage. Similarly, I took another single phase inverter. which is applied with the same input voltage. It is not V1, we take it as V in. So the output available across its output terminals is V02. Similarly, I take another single phase inverter. V03. So you suppose that it is required to step up or step down these voltages. So what I do is I am using a transformer. So for the sake of convenience, I change the color of the transformer here. Okay. So these are the primary windings of transformer. The outputs of the three inverters are connected to primary windings and the loads are connected to secondary windings of the transformer. So I connected the three inverters like this. So how the secondaries of these three transformers may be connected? The three secondaries of the transformers may be connected in delta fashion or in star fashion, isn't it? So how they are connected in delta fashion or star fashion? It is very simple to understand. If all the points are connected to a common point, this is the connected to ground. We call it as the neutral point. This is A and this is B and this is C. So that this is BAN and this is BBN and this is VCN. So this connection is called star connection. We call it as star connected secondary. So we have studied how three or more three resistors can be connected in a star fashion and delta fashion. The similar ends are joined to a common point, then that connection is known as a star connection. So I am joining the neutrals of all the transformers and I am grounding them. So that kind of connection is known as star connection. In this manner, we can obtain a star connected secondary for a transformer. Okay, now we see how it is possible for us to obtain the delta connection. So the endpoint of first winding is connected to the starting point of second winding and the end point of second winding is connected to starting point of this third winding and this point is connected to like this. So this is what we call it as A and this is called as B and C. So this voltage is VAB and this is VBC and this is VCA. And this connection is known as a delta connection. So in a delta connection, what happens is we have three windings like this: A, neutral, and B, it's neutral, and C, it's neutral. All these are joined. So this is A, this is B, this is C. Because it is connected to B, we take it as B. It is connected to C, we take it as C. It is connected to A, we take it as A. So this is BAB, and this is BBC, like this. So this point is B, this point is C, and this point is A. Like this, it is possible for us to connect these secondaries of the transformers in any of the fashion as we like. That is the one advantage of using three-phase wave inverter. So the first advantage is it is possible for us to produce output voltages that are displaced with respect to each other by 120 degrees electrically. The second one is it is possible for us to connect the secondaries of the transformers in any fashion that we like to connect. Okay. The third advantage is a three-phase system can transfer power efficiently, and it is possible to obtain, it is possible for us that we can get higher magnitudes of voltages in comparison with a single phase system. So these are the advantages of a three-phase system. So what we do, how we achieve this? Here, we suppose that the trigger pulses for these switches that are present in this inverter are applied at 0 degrees. Then the trigger pulses to the second inverter are applied with an electrical displacement of 120 degrees with respect to this. That means we apply a delay of 120 degrees to the second inverter. And with respect to the first one, the third one is delayed by an angle 240 degrees. 240 degrees. This is how it is possible for us to control the inverters. As a result, it is possible for us to obtain three-phase voltages across the secondaries of the transformer. Okay. Suppose if there is no transformer, no need to worry, because there is no transformer in the circuit. Then also it is possible for us to obtain the three-phase voltages. How? By suitably connecting the switches or the output terminals of the bridge circuit. For example, here I want to have a star connection. Just I join like this. So this will become my A phase, this will become my B phase, and this will become my C phase. So all the inverters are connected in star fashion, isn't it? So suppose if it is required for you to obtain the delta connected input, then it is possible for us to obtain the delta connected also. Have you obtained the delta connection? Yes, you join this one. So this will become our B. You join this one. This will become our C. You join these two. This will become our A. Like this, we can obtain the delta connected bridges also. Okay, this is how it is possible for us to obtain either a delta connected one or a star connected voltages across the output terminals of three phase converters or three phase inverter. So how this three phase inverter is converted? By interconnecting three single phase inverters. What we are doing? We are interconnecting the three single phase inverters. So now we jump into the concept. Here, a three phase square wave inverter. Why I used this word square wave is that the output available across the converter terminals is a square wave in nature. Okay. So the three phase inverters are used for high power application. As I told you just now, a three phase system can deliver more power in comparison with a single phase system, isn't it? So three phase inverters are normally used for high power application. Here you can connect either three phase half bridge or full bridge inverters in parallel. This connection, what we call it as a parallel connection. You know that the upper terminals are connected to the positive bus, whereas the lower terminals are connected to the negative bus. So it is, I can say that inverter 1 is connected in parallel with inverter 2 and inverter 2 is connected in parallel with inverter 3. So by connecting three inverters in parallel, it is possible for us to obtain a three phase inverter configuration. So the figure to form the configuration of a three phase inverter, the first one. And the gating signals, you know that inverter contains switches in it. Okay, so that each inverter is applied trigger pulse in such a way that they should be advanced or delayed by an angle of 120 degrees with respect to other phases to obtain a balanced three phase voltage. To obtain balanced three phase voltage. For that purpose, what we require is, here we need three single phase transformers. This is transformer 1, transformer 2 and transformer 3. We require three single phase transformers and we need 12 transistors and 12 diodes. The purpose of using this diode in an inverter circuit is to avoid a reverse flow of current from the load to source. Okay, due to the development of power electronic devices, nowadays these transistors and diodes are replaced with IGBTs, insulated gate bipolar transistors. So the output voltage of single phase inverters are not perfectly balanced in magnitudes and phases, then the three-phase output voltages are unbalanced. That means you should take enough care that the output of the three-phase inverters must be balanced. Otherwise, then what happens is there is a possibility that you can get unbalanced output voltages at the output terminals of the inverter. So, it is there is a need for us to balance the output voltages. Okay. Next, we see what are the modes of operation. Here, if you observe, a three-phase output can be obtained from a configuration of 6 transistors and 6 diodes arranging as shown in figure. Arranging them in the figure. This is what we call it as a leg. So, this leg is corresponding to phase A and this is corresponding to phase B and this is corresponding to phase C. And these capacitors are used to balance the input voltage. To balance the input voltage. Okay. So, the control signals that are applied to these transistors Q1, Q4, Q3, Q6, Q5 and Q2 in such a way that each transistor may be either can conduct for a period of 180 degrees in angular displacement or sometimes each transistor is allowed to conduct only for a duration of 120 degrees. Okay. So, if the switches will conduct for 180 degrees, then we say that the conduction is 180 degrees conduction. If the switches conduct for a period of 120 degrees, then we call it as 120 degrees conduction. Okay, next line lo undandi. So, first we see the operation of 180 degrees conduction mode of operation. That means the thyristors or the switches that are present in the circuit will conduct for a period of 180 degrees. You know that the angular displacement of one cycle is 360. So, if each thyristor conducts for 180 degrees, then at any given instant of time, three switches will be in conduction.